Hey guys, welcome to the second part of this game development course, and in this one we're going to be covering how to do the force wave to push the ball around. Let's get started. Okay, so we're in the editor now, and the first thing that we're going to work on is the force wave that'll happen when we click the mouse. And to do that we're going to use a line renderer, but the first thing we're going to do is go in here and we're going to create a new script, and this is going to be called Force Visualizer. And we'll open that in Visual Studio. Okay, so we're going to leave these two functions in, and we're just going to make a few variables. This size is going to be the number of points in the line renderer, and we're going to need a theta scale for the math in creating the circle, and we're going to need a boolean for fading the force wave. And we're going to need a line renderer, which we're just going to use getComponent in the start function to reference. Oops. Okay, and then we're going to need a default color, which is just going to be white. And then we're going to need a current alpha, so that when we're fading it, we can continue to fade it smoothly over time. And that's just off start going to equal 1, and we're just using color.white because it's easy. So in the start function now, what we're going to do is initialize the render, but we'll come back after we write that function. So now we're going to do the initialize renderer function. So we'll do private void initialize renderer, and we're going to write line renderer equals getComponent line renderer, and then we need to specify a material for it, and this is how you would reference one of the materials that already exists, but we're going to find it so that we don't have to do it through the editor. Okay, and now we're going to use line renderer dot set width. Oops. Oh, it's a material. Oops. Set width 0.6. Oh, 0.06f. 0.06f. And now we're going to do line renderer dot shadow casting mode equals Unity Engine rendering that shadow casting mode off, so we don't cast shadows. And then we're going to do line renderer dot receive shadows equals false. Okay. Now on to the next function. We're going to write public void visualize force float radius vector2 position, and in this function we're going to be drawing the force wave. So the first thing we're going to do is line renderer dot material dot set color, and all line renderers use tint color to change the color of the line, so we need to change the color of the tint color to not collection is color dot white, and oops, and we just want to, after that we're going to work on the math of the circle. So we're writing setting the size value, so 2.0f times mathf.py. Oops. And we're going to divide that by the theta scale, and that's just going to be our size value. And then we're going to round up size to an int. Well, not round up, but we're going to round it to the nearest integer by casting it. We're going to do size plus plus. We're going to do float theta equals 0f. and then line render dot set vertex count size, and then I'm going to write another function out of here, and I forgot the semicolon here first. And over here we're going to write function for drawing a circle, private void draw circle, use float radius, vector to position, and float theta. And in here we're going to first declare a vector 3 position, and then we're going to iterate through the size of the line render, so the number of vertices. So I is less than size, and then I plus plus. And in here, I'm going to do theta plus equals 2.0 f times math f dot pi. Divide this by theta scale, or I'm sorry, we need to multiply this by theta scale, and that's for that. And over here we're going to declare float x equals the radius times math f dot cosine of theta, and float y, we're going to do the same thing except with sine. Okay, now we're going to do x plus equals position dot x, and y plus equals position dot y. And now we're going to do pose equals new vector 3, x, y, and 0, because we're only doing it on 2D. Oops, don't know why that was doing that. Now we're going to do get components, line render. Actually, we can just do line render dot set position, I, and position. Okay. Now we have 2 more functions to do. And this is going to be public, actually. Public void fade, for once we actually fade out the force wave. So we're going to do fade force wave equals true, and we're going to change that in the update function. And over here we're going to do public void stop fading. And this is going to, of course, set the boolean to false. And then we're going to change the current alpha back to what it was before. Okay. So now we're going to go back up to the start function, and here we're going to call initialize renderer. And we also in here need to call draw circle with the radius, the position, and with theta. And then in the update function, we're going to do if fade force wave current alpha equals mathf.lerp. We're using a lerp to get a smooth effect on the fading out of the force wave. I'm going to multiply this by 20 just for the speed. It gets a nice effect. Color, new color equals default color, and then new color dot a equals current alpha. And now we're going to do line render dot material dot set color, and again we're accessing the tint color, and then we're going to do new color. And since we're doing this every frame, this will fade it out if the boolean is true. So now we're going to do current alpha percentage equals current alpha divided by default color dot a. We're going to multiply this by 100 to turn this into a percentage, simply so that we can make a boolean here if current alpha percentage is less than 0.1. So if it's very low, basically. And I have an extra parenthesis. My bad. We're going to do new color dot a equals 0, and line render dot material dot set color tint color. And then we're going to set it to the new color. Okay. And then after all this, we're going to stop fading, because we don't want to leave it in phase loop for once we restart the fade. Okay, and now the next thing that we have to do is just edit the input handler. So in here we have a lot of changes. So first we're going to start with just putting down all the variables again. So we're going to do public float force max radius equals 1.5f, vector 2 force position equals vector 2.0, and then we're going to do private bool exert force equals false, private bool can push equals true, private float current radius equals 0f, force visualizer, which is going to reference our other script as a component, fv is going to store that, and then public float force gun cooldown was 1f, we'll use that later, private float current radius percentage equals 0, and now we're going to do public, oops, this is actually, we're going to need to change this one, we're going to refactor this and call it get force position, since it's not only going to be using the mouse later on. And now we're going to need to specify a start function, and in there we're just going to access the visualizer component, and then in the update function we're going to change a few things. So in here we're going to write if exert force, actually we'll come back to this function because we have some other functions that we need to call in here. So we'll go over here and we'll write private void activate force wave, and in here we're just going to set current radius equals 0, force position equals camera.main.screen to world point. This will convert the mouse's position to, or anything's position really, to world point. So in here we're going to be using our mouse position for now. Exert force equals true, oops, not transform, and can push equals true. And then the next one we're going to do disable force wave. And in here we're going to write current radius equals 0, and then can push equals false, and exert force equals false too. Moving on, we're going to write the exert force function, which is probably our most important one. We need a vector 2 position, we need a float radius. So first thing we're going to do is fv.visualize force, and we're going to pass it the radius and the position, except as force position. Force position. There we go. Alright, now collider. Oops, collider 2D. Hit object. This is unarray. Hit objects equals physics 2D dot overlap circle all. And then we're going to do position and radius. And then we're going to iterate through that using a for each loop. And we're going to say collider 2D C in hit objects. We're going to check if its tag is equal to pushable. So c.tag dot equals pushable. And if we can push right now, I'm going to call a new function that we haven't written yet. So in here we're going to do private void push object vector to position and collider 2D C. And in here we're just going to do the math to push an object in the right direction based on the force wave. So vector 2 position equals new vector 2 c dot transform dot position dot x and also its y position, and semicolon there, rigid body 2D rig equals c dot get component rigid body 2D, and then rig dot velocity equals vector 3 dot 0. So we clear the momentum before we hit it because it gets a nicer effect on rebounding the ball around. Add force position minus position dot normalized times 1.5f to add a little force in there, and then we're going to force mode 2D dot impulse, since it's one burst, sort of like an explosion. Okay, and in here we're going to call if can push, and we're going to call push object position and C. And then in here we're going to call can push equals false. Okay, now we're going to go back up to the update function, and we're going to write if exert force, get rid of this, if we are able to exert force, then the current radius equals another lerp to make this grow smoothly and be in coordination with the visuals. Current radius force max radius time dot delta time times 30 to make it expand quickly. We're going to exert force position and current radius. Now we're going to calculate the percentage by dividing it. Current radius over force max radius times 100, and this is how much it's grown in comparison to how much it can grow. So in here we're going to do if current radius percentage is greater than 70, then we're going to write if we're not fading the wave, we're going to start fading the wave. Just because at about 70% the wave is going to be big enough to make it an interesting effect if it starts fading then. So now we're going to do if the current radius percentage is greater than 90, or 99, sorry, then we're going to just disable the force wave. And this is all we need to do for these two scripts. So now we're going to go back into the editor. Okay, so in the editor, oh, looks like I have an error. I need to remove one. Yep. Okay. We should be good now. Alright, so now in here we're going to create a new object just as the ball. So we're going to hit 2D object and sprite. And we're going to pick a sprite for it out of here. I'm just going to use knob for now. And we can scale this up a little bit holding shift and alt. And we can hit enter. And for the game controller, now we're going to add on the force visualizer script. And over here we're going to add a rigid body 2D. I'm going to set the mass at about 0.25, and we'll set the gravity scale at about 0.5. And the rest should work after we add a circle collider 2D. And now the ball should fall. It does, and hopefully we should see. Looks like the line render. Oh, I forgot. Okay, we forgot to add in over here require component type of line render. And since we have that, it should automatically add in a line render onto this one if we add it on. We never, over here we're supposed to be calling exert force and not, actually we're supposed to be calling activate force wave. Okay, and now it should all work properly. So we can see my force wave. However, the ball did not get pushed. Oh, I forgot to add a tag. And now we're going to have to add a tag, and we're going to call it pushable. So let's go over to the game, to the scene view, and we're going to go in here, and we're going to add in a new object. And it's going to be a sprite, and we're going to give it the picture of the knob. You're going to hit that, and holding Shift and Alt, holding Shift first and then holding Alt, and we're going to expand this ball just to make it a little bigger, and we're going to change the color to black just because it's nicer in my opinion. Okay, and so now we're going to add a rigid body 2D, and I'm going to set its mass to 0.25, and I'm going to set the gravity scale for 0.5, and now we're going to add a circle collider 2D just so that we can hit it, and then this should not be a child, and then I forgot actually to change this force max radius to 1. Okay, so now if we hit play, we're not hitting it because we forgot the tag over here. So if we tag this as pushable, then it should push just fine. So now we have our ball rebounding just right. Okay, so that's all we're going to be adding for this one, guys, and in the next tutorial we're going to be working on points and losing. So thanks for watching, and make sure to hit subscribe to watch the rest of these tutorials. See you later, guys.